DeepSeek Debrief, the real cost of cheap AI, 150 days later. China's big tech takes on global AI. Huawei, Alibaba, and Tencent's $60 billion overseas expansion. DeepSeek Debrief, the real cost of cheap AI, 150 days later. The landscape of artificial intelligence is undergoing a seismic shift, and the story of DeepSeek is a compelling case study in this transformation. Over 150 days have passed since the launch of DeepSeek R1, a Chinese large language model, LLM, that sent ripples through both the stock markets and the Western AI community. R1 was notable for being the first model to match the reasoning capabilities of OpenAI's models, but this achievement was quickly overshadowed by concerns over the potential commoditization of AI due to DeepSeek's incredibly low pricing, just 55 cents for input and $2.19 for output, a 90% reduction compared to the then-leading models. OpenAI, recognizing the competitive pressure, subsequently slashed the price of their flagship model by 80%, further intensifying the price war in the AI market. Since its initial release, DeepSeek has continued to evolve, with updates that have notably improved its performance, especially in areas like coding. This ongoing refinement reflects a new era in AI development, characterized by rapid iteration and continuous improvement. However, the journey of DeepSeek is far from smooth, and today we delve into its impact on the AI market and the challenges it faces. ##### A tale of initial success and subsequent decline. Upon its launch, DeepSeek saw a surge in consumer app traffic, leading to a significant boost in market share. However, tracking the exact extent of this growth is complicated by the fact that Chinese usage is often underreported, and Western labs are restricted in China. Despite this, the initial momentum did not last, and DeepSeek's market share has since declined. Web browser traffic to DeepSeek has actually decreased in absolute terms since its release, while other leading AI model providers have seen substantial user growth over the same period. Interestingly, the decline in user engagement with DeepSeek's own web app and API service contrasts sharply with the rapid growth of third-party hosted instances of DeepSeek's models. The aggregate usage of R1 and V3 on third-party platforms has grown nearly 20-fold since R1's debut. This raises a critical question. Why are users shifting away from DeepSeek's official services despite the low prices and growing popularity of its models? #### The Tokenomics puzzle. The answer lies in the intricate world of tokenomics, the economic principles governing the use of tokens in AI models. Tokens are the basic units of data processed by AI models, and understanding them is crucial for grasping the dynamics of the AI market. AI models learn by processing tokens and generate output in the form of text, audio, images, or actions. Each token is a small piece of text, such as fan, TAS, or tick, that the model processes rather than whole words or letters. In the AI industry, data centers are often likened to factories, with tokens serving as the raw materials and finished products. The revenue generated by these AI factories is determined by the P/Q equation, where P is the price per token and Q is the quantity of input and output tokens. Unlike traditional factories, the price per token is a variable that can be adjusted based on various performance metrics, or key performance indicators (KPIs). ##### Key KPIs in AI model serving. 1. Latency or time to first token. This measures how long it takes for a model to generate its first token after receiving input. It is also known as the time to first token, TTF, and is closely related to the prefill stage, where input tokens are encoded into the model's memory before generating output. 2. Interactivity. This refers to the speed at which tokens are produced, typically measured in tokens per second per user. Some providers measure the inverse, known as time per output token, TPOT, which is the average time between each output token. Human reading speed is about 3 to 5 words per second, but most AI models aim for output speeds of 20 to 60 tokens per second. 3. Context window. This is the number of tokens the model can keep in its short-term memory before older tokens are discarded. Larger context windows are beneficial for tasks requiring coherent reasoning over large datasets, such as analyzing documents or code bases. These KPIs can be manipulated to achieve different price points, making it important to consider the specific requirements of the task when evaluating the cost per token. For example, a model optimized for low latency might be more expensive per token than one designed for high throughput. #DeepSeek's strategic choices. To understand why DeepSeek has lost market share on its own platform, we need to examine the tokenomics of its R1 model. When plotting latency against price, it becomes clear that DeepSeek's service is no longer the most cost-effective option. While DeepSeek can offer low prices, it does so by forcing users to endure longer wait times for the first token. Other providers, such as Parasale and Friendly, offer similar prices with much shorter latency. Microsoft Azure, for instance, charges 2.5 times more than DeepSeek, but provides a 25-second reduction in latency. Since this data was collected, the situation has worsened for DeepSeek, with most R1 instances now hosted with sub-5-second latencies. Another trade-off DeepSeek makes is in the context window. By running a 64K context window, one of the smallest among major providers, DeepSeek limits the model's ability to handle complex tasks like coding, which require a larger context to maintain coherence. At the same price, users can get more than 2.5 times the context size with providers like Lambda and Nebius. #Hardware and compute constraints. The hardware behind DeepSeek's models reveals further insights. Benchmarking tests with AMD and NVIDIA chips on DeepSeek v3 show how providers optimize the price per million tokens, $/MTOK, by batching multiple users on a single GPU or cluster. This increases the total wait time and reduces interactivity, thereby lowering the cost per token. DeepSeek's strategy involves extreme batching to minimize compute usage, allowing them to allocate more resources internally for research and development. DeepSeek's focus on achieving artificial general intelligence, AGI, means they are less concerned with monetizing their models through user experiences. By open-sourcing their models, they ensure widespread adoption and mind share, while keeping their compute resources dedicated to advancing their core mission. Export controls have limited China's ability to serve models at scale, but this has not hindered their capacity to train effective models, as evidenced by recent releases from Tencent, Alibaba, Baidu, and Rednote. #Comparisons with Anthropic. In the AI world, compute power is the ultimate determinant of success. Anthropic, like DeepSeek, faces compute constraints and has focused on developing models for specific use cases, such as coding. Their model has gained significant traction in coding applications like Cursor, which has become a benchmark for user satisfaction, emphasizing both cost and experience. Anthropic's success in coding has led to the launch of Claude Code, a terminal-based coding tool that has outperformed OpenAI's Codex. Google responded with Gemini CLI, a similar coding tool that leverages the company's compute advantage with TPUs to offer unlimited request limits at no cost. Despite its superior performance, Claude Code is relatively expensive, and Anthropic is under pressure to manage compute resources efficiently. This is reflected in the reduced output speed of Claude for Sonnet, which has slowed by 40% to just above 45 tokens per second. Comparable models from OpenAI and Google run much faster, highlighting the compute limitations faced by Anthropic. #User experience and token efficiency. While Claude's speed is a reflection of Anthropic's compute constraints, the overall user experience remains superior to DeepSeek's. Claude's models require fewer tokens to answer questions, resulting in a lower end-to-end response time. This efficiency is a significant advantage, as models like Gemini 2.5 Pro and DeepSeek R1-0528 are more verbose, using 3 times as many tokens to complete tasks. Claude's lower token usage demonstrates that intelligence per token is a critical metric in AI model performance. The rise of inference clouds. The growing popularity of GPT wrappers and AI token-powered apps like Cursor, Windsurf, Replit, and Perplexity has driven a shift in the AI market. Companies are increasingly focusing on selling tokens as a service rather than offering monthly subscriptions. This trend is exemplified by the success of Anthropic, which has positioned itself as a leader in the inference cloud space. What's next for DeepSeek? As DeepSeek navigates the challenges of the AI market, rumors of a delayed R2 release add another layer of uncertainty. The company's strategic decisions, including its focus on AGI and compute optimization, will continue to shape its trajectory. Whether DeepSeek can regain its momentum and compete effectively in the rapidly evolving AI landscape remains to be seen. What do you think? Is DeepSeek's approach to tokenomics and compute management sustainable in the long run, or will it need to adapt to stay competitive? Share your thoughts in the comments below. China's big tech takes on global AI. Huawei, Alibaba, and Tencent's $60 billion overseas expansion. Imagine a world where the tech giants of China are not just dominating their home turf, but are also making significant strides on the global stage. This is not a distant future, it's happening right now. Major Chinese cloud service providers, CSPs, like Alibaba, Huawei, and Tencent are aggressively expanding their reach into the global AI markets, investing heavily in infrastructure and innovation. But here's where it gets controversial. This expansion is not just about business, it's about geopolitical influence and competition with American CSPs. Chinese AI firms, which have already established a strong foothold in their domestic markets, are now setting their sights on the global AI industry. This move is not going unnoticed by the United States, which views it with a mix of caution and concern. According to a report by the Taiwan Economic Daily, the CSP divisions of Alibaba, Huawei, and Tencent are actively working to compete in the global cloud segment. These firms boast capable AI models and hardware that are seen as viable alternatives to Western offerings. Developing AI infrastructure is the next big frontier for governments and tech firms alike. Companies like Nvidia and Huawei are poised to capitalize on the billions of dollars expected to be invested in this sector. Alibaba Cloud, for instance, has allocated over 400 million yuan to accelerate its global AI expansion. The firm already operates data centers in more than 29 regions outside of China, with a strong presence in Asia, including countries like Malaysia, Thailand, and the Gulf states. While Chinese CSPs may not yet match the capital expenditure (CapEx) of their Western counterparts, they are focusing heavily on engineering innovations. A prime example of this innovation is Alibaba's Qwen 2.5 Max, which is said to compete against industry giants like OpenAI and Anthropic in multiple benchmark tests. This is despite the perception that Alibaba's AI hardware capabilities are inferior. Similarly, DeepSeek's R1 and the upcoming R2 large language models, LLMs, are claimed to offer stiff competition to their Western counterparts. In terms of hardware, China is currently behind the United States, but domestic firms like Huawei are making significant efforts to expand their influence in neighboring regions. Huawei's Ascend chips, for example, are already being used in Malaysia, marking a significant step in their global expansion. The expansion of China's AI firms into global markets signals an intensifying competition for American CSPs, particularly in regions like the Middle East, where both the US and China are vying for dominance. And this is the part most people miss. The race for AI supremacy is not just about technological advancements, it's about shaping the future of global technology and geopolitical influence. So, what do you think? Will Chinese AI firms continue to make inroads into the global market, or will American CSPs maintain their dominance? Share your thoughts in the comments below, and let's spark a discussion on this fascinating and complex topic.